Hello, this is section 8, and this is the composition of functions. And the objectives are to talk about adding, subtracting, and multiplying dividing functions. In other words, doing arithmetic on them. And then find the composition of one function with another function, and to do an application. Okay, so arithmetic on functions, this is very straightforward. And since they're so basic, I'm not going to go over here. I'm going to do it on a warm-up exercise in a handout. So with functions, you can add them, and this is the notation that you use, and that's called the sum. You can subtract them. This is the notation you can use. That's called the difference. I'm going to multiply them. This is called a product. And then if you divide them, you can use this notation, and that's called a quotient. Now in calculus, there are special rules for doing calculus and all these kinds of functions. So that's one reason I'm bringing it up. But they're basic, and like I say, we'll do a warm-up exercise at handout. I'd rather not spend time here on that. So we're going to get into the notion of composition of functions, and that's when you use one function's output as the input of another. So it's like a chain. And the simplifying, and then you simplify them. And this is really important. Good skill to have in both this class, but calculus and other classes. So here's an example of a kind of a multi-step process. I'm going to give it to you just sort of verbally, and then we'll talk about how to think of it mathematically in terms of this thing called function composition. So here's an example. It's take a square root of 5x plus 1, then you square it, and then you add 2. So again, that doesn't mean much. You take the square root. That's the first thing we do. It's right here. And then we square it and add 2, and those are these two steps right here. So mathematically, we can think about it this way. Let that be one function, f of x, the square root of 5x plus 1, and let g of x be the squaring and adding 2. So this would be my g of x right here, and then right here would be an f of x. Okay. Now, this gets when we combine them, I'm going to plug f of x into g of x, and that has this special notation. And note, we start from the inside out. Like we'll do f of x first, and then we go to g of x. So we're going to continue this on the next slide. So that's where we were. We had that oral process, verbal process, and then this was the first step, and then this was the second step, the squaring and the adding 2. Okay. Now I said we want to evaluate this, so I want to explain what this notation means. And basically it says replace every x in g of x by f of x, and then evaluate. So here we go. G of f of x. Well, that means replace this x squared by f of x squared, which I do here, add 2. I have to go back and see what f of x is. That's what f of x is, and I don't want to forget to square it. And I add 2. When I square it, I get rid of the square root, and I get 5x plus 1 plus 2, and that simplifies to 5x plus 3. So again, that's what we did before. We said take 5x plus 1, take the square root, square it, and then add 2. And all that simplifies to x squared. Sorry, there should be a 5 here. There, to 5x squared plus 3. Okay, so this is a way to sort of mathematize and put notation on that verbal command. Okay, so I'm going to let you try one. So we have f of x equals 7x minus 1, and g of x equals 2x plus 3, and we're going to use this as the input of g of x. That's what this tells us. This is my input right here, f of x. A couple things to keep in mind. This tells you to replace every x in g of x by f of x, then do as g of x commands. And this notation, g of x, that's what we use, and that also means you first plug in f of x and g of x, and then do as g of x commands. And then this notation is sometimes written as this with a little circle in there. And I prefer this notation, but our book and WebAssign use this one, so we'll use that one too. Okay. So again, pause, work on this, and then meet me on the next slide. I'm going to head to the next slide now. Okay, So hopefully you worked on this. This is what we wanted to work on, which is plugging in f of x into g of x, which means replacing every x here by f of x. So again, I'm going to use f of x in red just so we can follow. So that's my f of x, and that's g of x. So g of f of x means I plug in f of x for x here. So I get 2 of f of x squared, and I add this 3, and so then I'm going to multiply that out. And I think I haven't done much FOILing, but I think I want to do a little bit. That's going to be 7x squared. But I'll do that in a little bit. So again, this is just sort of summarizing what I just did. So I want to look at that. And I squared, and that looks like that. So I'm going to FOIL out the 7x plus 1. And that's the first thing I do, so I get 49x squared. Then I take 7x and multiply it by that one. Then I take 1 and multiply it by that 7x, which is another 7x. And then 1 times 1. And that's 1. So I add all this together, and I get 49, 14x plus 1. And I forgot that we put the 2 here. So I need to multiply 2 by that. Should be a 1. And then add 3. And so I'm going to get 98x squared. 2 times 14 is 28x. 2 times 1 is 2, and then I add 3. So when all said and done, I get 98x squared plus 28x plus 5. And that is what this equals. Okay, so we'll do another. Actually, we're going to do 2. So we're taking 2 functions, and I want you to do both of these. I want you to do this and this. And I'm going to ask you a question. Will the answers be equal? So here are some reminders. It's 2 problems. G of f of x means plug f of x into every x in g of x, and then do as g of x commands. F of g of x means first you plug g of x into every x in g of x, and then do as, sorry, there should be an f here. Yeah, plug g of x to every x in f of x, and then do as f of x commands. And do you think these 2 answers will be equal? Again, you know the drill. Pause, work on this, and see me in the next slide. I'm going to go to the next slide now. Okay, so hopefully you did some work on this. And so first I'm going to do this one, and then in the next slide we'll do this one. Again, I want to remind you of that other notation since the book and WebAssign use it. So g of f of x is going to be g of x of 2. That means that I'm going to plug in my f of x is equal to x plus 2. So that means whenever I see an x in g, I'm going to plug in x plus 2. So I do that here. Then I get 4 minus this. And again, I'll show you how I get that, how I get the x squared plus 4. I get that, I get my x squared. I multiply x times 2, I get 2x. I multiply 2 times this x, and I get 2x again. And then I'm going to multiply 2 times 2. I get 4. So 4x, x squared and 4. So I get that. Okay, and then I distribute, so I get a minus. Everything becomes a minus. That and that cancel. And I'm left with minus x squared minus 4x. So that's what that equals. Okay. Now we're going to go doing this one on the next slide. So again, just to remind you, that's f circle g of x. And I'm going to look at f of g of x. That's my g of x right there. So that's what happens when I plug in g of x. And then wherever I see an x here, I'm going to plug in 4 minus x, which is what I do. And then I distribute, and I get 4 minus x squared plus 2. I get 4 plus 2. I add those together, and I get 6. So this is going to be my g. Sorry, this is backwards. This is going to be my f of g of x. Now notice I get these things that are not the same. And that was one of the questions I had, because remember, squaring and adding is not the same as adding then squaring. Just keep that in mind. Okay, just a little bit of thinking about this. It's a two-step process. First, you evaluate the inner function, and then you apply f of x to the output of g of x. So here's an example, and I'm going to look at the example x equals 3. So first, I plug 3 into g of x, and I'm going to get 4 minus 9, which is minus 5. And then that minus 5 goes in here. So that's going to be f of minus 5. And so I'm going to get g of x, which is minus 5, plus 2, which is minus 3. So kind of it's a chain. That's the way I think about it. It's like that. And that's what they're trying to make here, that you do x, you plug it into g to get g of x, then you take that and plug it into f to get f of g of x, or you can just use this notation for the whole process. So again, the domain of g is over here. You plug that in, and that goes into the domain of f, and then f takes it over to its range. And that's all the point they're trying to make there. Okay, just a couple of ways to think about it. So here's an application. This is the last thing we do, and we have T, and T here is going to be temperature. Capital T. That's what capital T is, and this little t over here is time. Okay. And you can think of T as hours. I forgot to mention that. Okay. So we want to find the composition and interpret its meaning, and then we want to find the time when the bacteria count reaches 2,000. So the idea is that food spoils. This is when it's in the refrigerator. You take it out of the refrigerator. There's already something present in there, some bacteria, just a little bit, and then it's going to just accelerate when it gets into the air because it's happier. Okay, so again, find the composition of this composed with this, and then find the time with the bacteria count. So pause, work on it, and check out the next slide when you're done. Okay, I'm at the next slide, and I'm just repeating the information here. Again, this is hours. And so I want to find this composition, N of T, and then find when the time when the bacteria count reaches at 1 decimal point. Okay, there's a lot going on. So it's common in math to mix stuff like that, those same concept using different letters. I find that annoying. And even though T is a function of T, and so it should be written like this, it's also it's also common just to write the T as we do there. That just is the way it is. It's annoying. So with this in mind, I think of N of T. I immediately start thinking of it as N of T, capital T of little t. And so then that means I'm going to take this little t, T of little t, and plug it in for every t I get here. So I plug it in, square it, then I plug it in here, multiply times 80, and then I add 500. So now I want to look back to what my other function is. Little t is 4t plus 2. So I'm going to plug that in here and into here. So go to the next page. And again, summarizing what the last page was here. And we took N of T, we wrote it as T of little t. And then wherever there was a capital T of T, we're going to plug it in to N for the capital T's. And so I get 20 capital T of T squared minus 80 capital T of T plus 50. And so my capital T of T is 4t plus 2. So I'm going to plug that in here. And I add 500. So that's where I was. We need to find this composition, which we're in the process of doing, and interpret it. Then we want to find the time when the bacteria count reaches 2,000 to 1 decimal point. Again, so I'm indicating in red that what we're doing, we've plugged t of t n to the t's and n right here. Again, we're going to multiply things out. When I square this, I'll let you do that on your own. This is what I get. 80 times 4t is going to be 320t. 2 times 80 is minus 160 plus 500. And then I distribute 320t squared, 320t, 20 times 4 is 80. Then I get minus 320t minus 160 plus 500. Notice that I've added those two things here, and I've gotten 340 over here. So now we take the 80 to the 340, and I get this. And conveniently, this and this are the same, so they cancel. So all comes down to 320t squared plus 420. So that's what my N of t boils down to after all those computations. So we found the composition. Now what does that mean? Well, that's the number of bacteria at time t in hours. And notice that t is the only variable left. So that's good. Now for part 2 here, we need to find t. So we're going to set 200 equal to this and solve for t. So I'll do that on the next page. Again, so summarizing what we did, we simplified this composition to just a function of t. We need to answer b. So that means we want to find out when the bacteria count each is 2,000. So I'm going to set this equal to 320 t squared plus 420 and solve for t. So that's what I do here. So that's equal, 2,000 is equal to 320 t squared plus 420. I subtract minus 420 from both sides. That goes away. So I have 320 t squared equals, do that work, I get 1580 equals 320 squared. I divide each side by 320. And then I get this. Now I take square roots of both sides. I only need the positive root. And why? Because we're looking at time. And our interpretation of time here is positive. It's time after we take it out. And also, if you look back on the constraint of t, it says that it's going to be 0. So by that, let's look back here to the very beginning of the problem. And look, t has to be positive right there. So that means we only go for the positive root. So again, that's stuff that's important to keep in mind. So I solve this, plug it into a calculator, and I get that that's about equal to 2.2. And this is ours. So I want to make note of that. Okay, so that's it. So if you have any questions, we can talk about this in class. Okay. Bye-bye. Thank you.